In this video, we're gonna try to solve some differential equations with the use of solutions by substitutions. Now, we have a differential equation here, x dy over dx is equal to y plus squared of x squared minus y squared, where your x is greater than 0. Now, to find the solution of this differential equation here, we must change this to the format dy over dx is equal to f as a function of y over x, or you can also use this format dx over dy is equal to g as a function of x over y. Now, if you use this first here, first equation, you will let u is equal to y over x, and if you use the second equation, we'll use the v is equal to x over y. Now, let's try to change this in one of those forms. Now, we'll multiply 1 over x to both sides of the equation, canceling the x. We're left with dy over dx is equal to 1 y over x. Since 1 over x distributed to y, we have y over x plus square root of x squared minus y squared over x. Now, take note here that our x is just equal to square root of x squared, since the values of x is greater than 0. So it can neglect the negative. So we have dy over dx is equal to y over x plus square root of x squared minus y squared over x squared is equal to y over x plus square root of x squared over x squared is just 1. So minus y squared over x squared is just quantity y over x and raised to square. Now, since we can notice here that our expression has y over x in the right hand side and our left hand side is in the form of dy over dx, so we'll use the first one and we'll let u is equal to y over x, and we'll take and also y is equal to u times x. Now we'll take the derivative of that with respect to x by implicit differentiation. Our y is equal to ux. Now the derivative of that is dy over dx is equal to u times dx over dx, but our dx over dx is just equal to 1, so we can neglect that and we'll write u instead, plus x times the derivative of u with respect to x. Now, we have our value of dy over dx in terms of u and x here, so we'll plug that in here in our left-hand side expression. U plus x du over dx is equal to our y over x here is just equal to u, so we'll plug in u here is equal to square root of 1 minus u squared. Now, our u is in the left-hand side expression and our right-hand side expression, so we can cancel that out and we're left with x du over dx is equal to square root of 1 minus u squared. Now, multiplying both sides of the equation by dx over x so that we can separate the variables. We have now du is equal to square root of 1 minus u squared times dx over x. Now, we'll multiply 1 over square root of 1 minus u squared to both sides of the equation to separate the variable. All the expressions in terms of u must be in the left-hand side, and all the expression in terms of x must be in the right-hand side. So we have du over square root of 1 minus u squared is equal to dx over x. Now, next is to integrate both sides of the equation. The integral of du over square root of 1 minus u squared is just arcsine of u. And our integral of dx over x is just the natural logarithm of x. And we'll put the constant here, but our u is equal to y over x, so we'll change our solution in terms of, we'll change the u to y over x so that our solution is in terms of y and x. So we have this here. This is our solution. Arcsine y over x is equal to ln of x plus c. Now let's try another problem here. We have xy squared dy over dx is equal to y cubed minus x cubed. With our given initial condition, y of 1 is equal to 3. Our y value is 3 when our x is equal to 1. So we have dy over dx in this form, and this term here, the coefficient of dy over dx is just one term. So we'll try to divide that to both sides of the equation. So we'll try to multiply 1 over x y squared so that we can cancel xy squared in our left hand side. And we're left with dy over dx is equal to y cubed minus x cubed all over xy squared. Now, this is y cubed over xy squared minus x cubed over xy squared is equal to y cubed over y squared is just y, so we have y over x here minus x cubed over x is just x squared, so we have x squared over y squared here. As you can notice here, we have dy over dx is equal to y over x, but our x squared over y squared is not in the form of y over x, so we'll change that in the form of y over x, so that we'll have this form here, dy over dx is equal to f as a function of y over x. So we have y over x here minus 1 over y squared over x squared, y over x minus 1 over quantity y over x raised to 2. Now we've already and successfully changed that into this form, so we will let u is equal to y over x, and our y is equal to u times x. Now the differentiation with respect to x is dy over dx is equal to u, dx over dx is just 1, so we have u here plus x du over dx. So we'll plug this in here in our left hand side expression. U plus x du over dx is now equal to, or y over x is just u minus y over u squared. Canceling out the u, we're left with x du over dx is equal to negative 1 over u squared. Now trying to separate the variables, multiplying u squared dx over x, we have canceling out the x, and we're left with canceling out also the dx, so we have u squared du is equal to negative dx over x. But I want the negative to be in the left hand side, so I'll move that negative in our left hand side expression. So negative u squared du is equal to dx over x. Now integrating both sides of the equation, we have negative 1/3 u cubed is equal to the natural logarithm of x plus a constant c. Now our u is just equal to y over x, so we have u is equal to y over x. So we'll plug that in here so that our solution is in terms of y and x. So we have negative 1/3 times y over x raised to cube is equal to ln of x plus a constant c. And we'll find the value of c given our initial condition y of 1 is equal to 3. Our x is just equal to 1 and our y is equal to 3. So we have negative 1/3 times our y is 3, our x is 1. So we'll plug that in here. Cube is equal to ln of 1 is plus c, but our ln of 1 is just 0, so we can cancel this out, and our c is negative 3 cubed over 3, so we have negative 3 squared is negative 9. So our final answer is, and solution is, negative 1/3 quantity y over x cube is equal to ln of x minus 9, or C. This is our final answer. Now let's try another problem after this. Let's try to solve another problem. This is our next differential equation. We have x plus y e to the y over x dx minus x e to the y over x times dy is equal to 0, where with our given initial condition y of 1 is equal to 0. Now let's try to change this differential equation in the form of dy over dx is equal to function of f in terms of y over x. We have x plus y e to the y over x times dx is equal to x e to the y over x times dy. I'm trying to change the format. So we'll multiply both sides of the equation by 1 over x e to the y over x dx. So we have in our left hand side expression x plus y e to the y over x over x e to the y over x, cancelling out dx is equal to, cancelling this out, we're left with dy over dx. And you can notice here that we have this form dy over dx is equal to f as a function of y over x. We have y over x here, y over x, and we also have dy over dx here. But the other terms, we haven't changed still. So we'll change that. We'll try to change that in terms of y over x. So we have x over x e to the y over x plus y e to the y over x over x e to the x here e to the y over x. Now we have dy over dx is equal to 1 over e to the y over x, since x over x is just equal to 1, plus e to the y over x over e to the y over x is just 1, so cancelling that out, we're left with y over x here. And we have this form now, dy over dx equal to f as a function of y over x, so we'll let u is equal to y over x. And y is equal to u times x. So taking the derivative with respect to x is equal dy over dx is equal to u plus x du over dx. Now we'll plug this in here in our left hand side expression. So we have u plus x du over dx is equal to 1 over e to the y over x is just equal to, since our y over x is equal to u, so we'll change this to u plus y over x is just u, so u here. So u is in the both sides of the equation, so we can cancel that out. So we're left with x du over dx equal to 1 over e to the u, and multiplying e to the u times dx over x so that we can separate the variables. Cancelling out the x over dx, we're left with e to the u du is equal to e to the u over e to the u is just 1, so we can cancel this. And we're left with dx over x. Now next is integrating both sides of the equation. So we have integral of e to the u du is e to the u, and equal to Integral of dx over x is the natural logarithm of x, ln of x plus a constant c. Now our u is equal to